You'd think I'd be all gung-ho all about Scrum, but I'm not. I've seen Scrum do some damage in the industry and on teams. I've also seen it do good. So today we're going to talk about Scrum, the good, the bad, and the ugly. Hello world, I'm David Scott Bernstein, and I've been a software developer for over 40 years. First, I started out in waterfall, and I have scars to prove it. And then I moved to Agile in the early 2000s, and life became a lot easier. It solved a lot of problems, but it also created some problems and didn't address some issues in software development. Software development, I think, is one of the most complex activities that humans can engage in. And I think about three main things that Scrum has introduced that has really helped the software industry. The first one is breaking down big tasks into smaller tasks. And this is just a common technique in pretty much everything. It works in every domain where when we have a very large intractable problem, if we can break it down into smaller sections and solve the smaller problems, and then aggregate all those solutions up to solve the bigger problem. The other thing that I found that's really valuable about Scrum is having a product owner, someone who represents a unified voice for the product that's being developed, who really becomes the central repository for the software that we're developing is critically important. And notice this repository is human. It's not a document, because humans can learn quicker. Humans can assimilate knowledge quicker. And when we have a product owner, it means that we don't have to write a lot of stuff down. Scrum does two things to make this happen. Shortens the time horizon for construction of software. Instead of building to a release that's a year or 18 months, we build to our sprint, which is a month or shorter. Typically, teams will opt for about 2 weeks for a sprint. Because that time horizon is so short, we don't have to write a lot of stuff down in terms of requirements because we can keep it in our heads. That eliminates enormous amounts of overhead. How much overhead? According to an NIST study, it eliminates about 50% of our overhead. This study, and I'll put it in the show notes, it says that half of all of our time and energy is wasted in writing down and reading and interpreting requirements when we do waterfall, when we have requirements. And if we can eliminate that step, we can get back half of our time. Half of the defects that are created are from poorly conceived of or poorly understood requirements. So if we can get the written requirements out of the way, we can actually be in a more flow state and get more done. That's one of the things that Scrum brought to the table, I think, that is incredibly valuable. Okay. So the third thing, and I think this is also very valuable, that Scrum has brought to the table, and I think a lot of us have forgotten this, which is really making software development sustainable. Because, back in the 1990s, we were facing crazy deadlines, and so we didn't work in a sustainable pace. That is not a really good way to build an industry, nor is it a good way to build a career. I could do that when I was young, but I have no hope of doing that now at my age. And so we need standards and practices that support us in being able to build software sustainably. And Scrum really was an advocate for creating a sustainable community of software developers. So those are three things that I think are incredibly valuable for Scrum. But there are some bad things related to Scrum. And I think that comes from a real misunderstanding of what Scrum and Agile software development is. It's not a solution, it's a methodology. It's a set of approaches that enhance development, but it still requires us to think, to use our discretion, to know when not to apply the rules. And taking it from dogma to a practice that's practical and useful has been really challenging for a lot of organizations. Software development is complex and it's not very well understood, as evidenced by the data. Software projects are, by and large, not successful. I've encountered so many people who feel like, oh my God, it's something wrong with me because my software teams are not effective. Guess what? You're not alone. This is kind of the case in the world. And the challenge is that when you build software iteratively, like we do in sprints when we're doing Scrum, we have to take a different approach than we were typically taught. Because we were taught how to build software in a very much a waterfall context, where we come up with a plan and then we execute it. And then later we review it. And the challenge with that is that it means that the execution is really just following what we created before. But that is not the best way to think about and to design our systems. It's much better to think about our systems and design them in the moment as we're building it, because we see the forces in front of us. The whole process of writing software is actually to lay bare the process so that we can actually build something around it. This is so much more actionable than trying to visualize what that would be like, because the factors when we build software are constantly changing. So having a idea of the direction that we want to go is very good, but actually forming the plan is something that we want to do in the moment. I think it was Winston Churchill who said, planning is essential, plans are worthless. And I think that so applies, because the idea of planning is so important. We learn so much, but the plan itself, the end result, that's something that's up for change. That's something that is up for modification. And we oftentimes don't think of it that way. And I think that the thing that is the biggest challenge that I see with teams transitioning from waterfall to Scrum is that they don't have the technical practices to make that happen. Specifically, they don't know how to transform their designs from one design to another design. So they feel a lot of pressure to come up with the right design up front. But since we're getting incremental requirements, that's nearly impossible because we don't get all the requirements. So whatever design we do come up with will probably not accommodate future needs. And we don't know how to change our design to be able to accommodate those future needs. So we hack it in. And those things cause the quality of our software to degrade, which ultimately causes us to not be able to get any more work done. If you look around, you'll see a lot of Scrum teams in the first, second, third year, but you won't find many Scrum teams in their fifth, sixth, seventh year, because teams will have accumulated so much technical debt that it will be very hard for them to get much work done after that. There are ways to mitigate this by understanding how to pay off technical debt. And when we combine Scrum and other agile methodologies with the technical practices that support software development, and when we do these practices well, and it's easy to get them wrong, trust me, but when we do them well, we can make amazing progress, and we can build software that is resilient. That's the name of the game in software development. That's what we've missed over the last 2 decades, which is the robustness in code. We want to build software that lasts for the needs of the customer and is constantly able to be repurposed and changed. So we talked about the good, we talked about the bad. What about the ugly in software development and Scrum specifically? And, I don't want to just limit it to Scrum, because I see this symptom in other agile frameworks as well, specifically SAFe. The largest corporations and institutions are using SAFe, and SAFe and Scrum tend to ignore the technical practices that would give us the leverage to be able to do these practices well. And so once again, people are set off on these journeys, and they're very successful for the first couple of years until they've accumulated so much technical debt that they can't get anything done. And managers blame developers because they just saw last year that the team was doing amazingly well. And today, they can't get anything done. They're slipping on deadlines and stuff like that. So obviously, they're unmotivated. That is not what is going on. Let me tell you, I don't know anything about your organization, but I can tell you that it's probably likely that it's not your developers losing motivation, but rather that there's so much technical debt that it's hard to get anything done because we developers have not been taught how to deal with technical debt in a systemized, effective way. One of the books that I cherish is Martin Fowler's book, Refactoring, which teaches us how to transform code from one design to another design. It's so incredibly powerful. And it's a thing that we do all the time in software development, or should be doing all the time. So developers really need to understand this, but I rarely meet a developer who understands or has even read this book. But these are the things that we're going to be talking about on this channel. These are the skills of senior software developers. So if you're a junior software developer and you want to be senior, stick with me. If you're a senior developer and you want to improve your chops and learn some new things, we're going to talk about those things. And obviously these things are a bit controversial. Software development is a challenging field and it is a very intellectual field. And so there's a lot at stake for people. I understand that and I respect that. But it's a field of constant learning. And so learning is a very powerful and important part of being a software developer. When we recognize that, I think that it creates room for improvement, which is what we need. If we think that we're doing a perfect job, we won't ever look at what we're doing to examine if it could be better. But we can always do better. And so that's what I want to share with you, some of the things that I've learned from other developers that I deeply admire on how to do better. And so we're going to talk about the principles that underlie good software development. We're going to talk about practices that I've learned on how to build software in iteration successfully. And we're going to talk about how AI can help us become even better, highly productive developers. So I'll see you soon.